My dear students, welcome back to our lesson. We are still looking at transportation of oxygen. We have seen how hemoglobin and myoglobin are involved in transportation of oxygen. Now I think you can make a differences between the two proteins, between hemoglobin and the myoglobin, as far as their ability to carry, ability to load oxygen is concerned. Having seen that, now let's look at the adaptations to oxygen uptake. Adaptations to oxygen uptake by selected groups of animals. Adaptations to oxygen uptake, which are shown by different selected groups of animals. The first one, let us see adaptations to oxygen uptake by the mammalian fetus. Adaptations to oxygen uptake by the mammalian fetus. When we are talking of the fetus, this is an unborn baby. The young that is still developing in its mother's womb. How does it get oxygen? Does it breathe? Does it use its lungs? Does it take in oxygen from the atmospheric air? Does it breathe out? So that the carbon dioxide resulting from respiration goes directly to the atmosphere? Automatically not. This fetus is 100% dependent on its mother by most of its physiological activities. This is including gaseous exchange, is including elimination of excretory wastes and the likes. Normally, the fetus gets oxygen for respiration from the mother. It gets oxygen for respiration from its mother. And this oxygen diffuses in across the placental barrier. From the mother, oxygen goes into the fetus across the placenta. And the carbon dioxide resulting from respiration in the fetal cells diffuses across the placenta into the mother's circulatory system. Now, how is it that the fetus is capable of taking oxygen from its mother and not the other way around? Why does oxygen crosses the placenta from the maternal circulatory system into the fetal circulatory system and not from the fetal circulatory system into the maternal circulatory system? What is a reason behind? This is because the fetal hemoglobin has higher affinity for oxygen than the maternal hemoglobin, meaning that hemoglobin of the fetus has the ability to pick up oxygen, to load oxygen, even if its tension is lower than the affinity of the maternal blood. And that's why this fetus can take oxygen from its mother, and not the mother to pick oxygen from its fetus. And therefore, the oxygen dissociation curve of the fetal hemoglobin is displaced to the vertical axis side, while the maternal hemoglobin's oxygen dissociation curve is on the horizontal axis side. That is, we have percentage saturation, and this is partial pressure of oxygen in kilopascals. It is 20. So if this is the oxygen dissociation curve for the maternal blood, the oxygen dissociation curve for the fetal blood will be here. If this is loading tension, and here we have an unloading tension, this means that the fetal hemoglobin is capable of loading oxygen, even if the tension is as small as maybe, or as low as maybe 7 kilopascals, while the maternal hemoglobin will load oxygen when its tension is as high as maybe 15 kilopascals. So that hemoglobin, which is able to pick oxygen even if its tension is very low, is the one which possesses a high affinity for it. It means that it has the ability to take oxygen even if its concentration is very low. Now a question. What would happen if the maternal hemoglobin would have higher affinity for oxygen than fetal hemoglobin? If the maternal hemoglobin were to have a higher affinity for oxygen than the fetal hemoglobin, what do you think would be the effect? What do you think would happen, either to the mother or to the developing child inside? The second group, the second category to be considered, we have adaptations to oxygen uptake for mountain climbers. We talk of the mountain climbers or talk of high altitude dwellers. those mammals that live in high altitudes, or mountain climbers. What adaptations do they have as far as oxygen uptake is concerned? Of course, by living in there, or by having the habit of climbing the mountains, with the time, they develop some features that make them sweet or survive in those particular areas, because there are some conditions that have to be coped with, so that these organisms, these animals, these mammals survive there with no physiological or physical effects. The first adaptation is that normally they take extra deep breath. They take extra deep breath so as to take in more oxygen, and hence to ensure more carbon dioxide loss from the body. To take in more oxygen, and therefore to ensure more carbon dioxide loss from the body. We have seen that the affinity of carbon dioxide, of hemoglobin to either of these two gases will depend on which gas is in high concentration. So whenever we take in more oxygen, hemoglobin shifts its love to oxygen. And therefore, when hemoglobin is shifting its love to oxygen, the chances that carbon dioxide will be released out are increasing, because when oxygen-bearing hemoglobin reaches the tissues where the carbon dioxide is, with releasing oxygen there, carbon dioxide will automatically be picked up. But secondly, production of more red blood cells. They produce more red blood cells, and these red blood cells contains, of course, the greater the number of red blood cells, the greater the number of hemoglobin. So, with a large number of hemoglobin molecules, and this is to increase the carrying capacity of the blood, to increase the oxygen carrying capacity of the blood. Increases oxygen carrying capacity of the blood. First one, taking extra deep breath so as to take in more oxygen, and therefore to increase chances for carbon dioxide loss from the body. That is, their bone marrows are capable of synthesizing more red blood cells with a large number of hemoglobin. And with increased number of hemoglobin, there are increased chances for carrying oxygen, or increase the oxygen carrying capacity of the blood. Yes, apart from producing more red blood cells with a large number of hemoglobin, the third one, that they produce hemoglobin. They produce hemoglobin to produce hemoglobin with very high affinity for carbon dioxide. very high affinity for oxygen, sorry. They produce hemoglobin with very high affinity for oxygen. And this one helps it to load more easily which loads more easily. It loads oxygen more easily at low oxygen partial pressure. Apart from producing hemoglobin with very high affinity for oxygen, but also these animals have cells tolerant. They have cells tolerant to oxygen death. You can remember what oxygen death is from your form 2 gaseous exchange and respiration, meaning that their cells are capable of tolerating high concentrations of lactic acid without being damaged. They can tolerate high concentrations of lactic acid for a long time without being damaged. But also, they have expanded lungs. They have expanded lungs, and therefore they are capable of taking in much oxygen. Additionally, they produce a large number of myoglobin. To produce large number of myoglobin. Well, my dear student, remember I gave you a food for thought to go and find out why an oxygen dissociation curve is S-shaped. But also, I give you another question that explain how Mount Kilimanjaro climbers are adapted to oxygen uptake. And secondly, write briefly on Bohr effect. My dear student, well, we have now come to an end of our lesson today. In the case of any question, in case of any query, in case you haven't understood anywhere, or whatever communication, please don't hesitate to write to us either a normal SMS or a WhatsApp message through our number 0769 04 8594. 0769 09048594. Otherwise, you can follow us on our Instagram page, Elimika Darasa, or you can follow and subscribe in our YouTube channel. Until then, my name is Fortunato Schiobia. Bye-bye.